Okay, students. So far we have discussed the structure of the eye and the functions of the parts of the eye, and also you all have understood how images form on the retina of our eyes and how the lens is able to change its curvature so that we can observe close by objects as well as far away objects. Now in this chapter we are going to start off this with the defects of vision. So if you have a healthy eyes, then no problem. You can look at things that are close by or far away. You can look at all the objects clearly without any problem. But there can be defects of vision. So the first two eye defects can be identified in vision due to the eyeball becoming short or long. So you all can remember, students, normally we have a certain size for an eyeball. Normally it's almost like a spherical shape, but it can become too long or too short because of that, or else the inability to adjust the focal length of the eye lens to desired level. How does our eye adjust the focal length? I just mentioned it to you all. The curvature of the lens can change. When it is less curvature, the focal length is high. When the curvature is high, the focal length is less. So, if that cannot be done, then also there can be a defect to the vision. So, based on these two reasons, there are two types of defects. One is known as the long sight. Long sight or hypermetropia. Then the other one is short sight or myopia. So one is long sight, the other one is short sight. From the term, you should understand what the problem is. When we say long sight, we can see objects that are at a long distance. So, you can observe far away objects clearly, but it's difficult to observe the close by objects. So, there are people who can see things that are far away, but they find it difficult to read the book. That is long sight. When we look at short sight, you can see objects that are close to you clearly, but the far away objects will not be clear. So that is myopia. So both these, long sight or hypermetropia or short sight or myopia, the reasons for these two defects are the eyeball becoming short or long, or else the inability to adjust the focal length of the eye. That is, inability to increase or decrease the curvature of the eye lens. It can be either one reason or both reasons together that lead to these defects of vision. So with that, I will move on to the first type of defect, that is long sight or hypermetropia. A person having this defect can see far objects clearly, but close objects become unclear. So as I told you, you can see everything that is far away, but it's difficult to read a textbook because that's a close object. Then that condition is known as long sight. So the causes of long sight. Now you can understand, you can see far objects. Then the curvature of the lens has to be less. But if you want to see close objects, the curvature has to increase. So if that is not possible, then you cannot see close objects clearly. So one cause of long sight is the inability to increase the curvature of the lens. Then we discuss the size of the eyeball. So if the eyeball is too short also, then the image of a close objects will form behind the retina. Due to that also you can get long sight. So here the eyeball being too short. So, two reasons. The inability to increase the curvature of the lens or the eyeball being too short are the causes of long sight. And this long sight can be corrected by using spectacles. So, you all are familiar with that. Some of you all might be wearing spectacles. You know people who wear spectacles and you know they wear it for either long sight or short sight. And the spectacles that is used to, or the lens that is used to correct long sight is the convex lens. So, this defect can be corrected by using a convex lens. Normally, a convex lens can be used. When it comes to the spectacles, we call it a meniscus convex lens. So, with that, I will move on to the next slide where we try to understand how the vision of a person suffering from long sight takes place. So, here, the person can focus the rays coming from a distant object on the retina to form a sharp image. So, this is long sight. So, distant object forms a sharp image so that he can see distant objects clearly. We'll see how that happens. So, here we have the eye and we have the lens there. So, as you all know, when we say it is a distant object or a far object, what type of rays come from that? Parallel rays. So, here you can remember how we drew the ray diagram. The parallel rays falling on the lens and they converge onto the retina to form the image. So, that is for far object. But what happens when light rays from the nearby object? So, here it is the nearby object cannot be brought to focus on the retina to give a distinct image. That is the problem. So, let's see how that happens. So, here again, if we consider the eyeball there, that is the lens. Now, here the eye cannot increase the curvature or the eyeball can be too short. Both situations will lead to the same problem. Now, when it is a close object, what type of rays come from a close object? Divergent rays. So, here the rays are going to be divergent rays. And what will happen? Because the curvature cannot increase or because the eyeball is too short, it will converge behind the retina. So, if the image forms behind the retina, the information cannot be given to the optic nerve. So, you cannot observe the close objects clearly. So, this is the problem here. Far objects can be seen clearly because the image forms on the retina. But when the object is close by, it forms the image behind the retina. So, that's important. In this case, the image is formed behind the retina. So, because of that, as the rays get focused behind the retina. So, because of that, the image will not be recognized by the brain because the image information cannot be given to the optic nerve. So, this is the problem that leads to long sight. So, what are the reasons for long sight? One thing is the eyeball is too short, or curvature of lens cannot be increased. So those are the reasons that cause the long sight. So how can we rectify it? Now we can't change the size of the eyeball. We can't make it longer. So but we can help to focus the light onto the retina. Here, because the curvature of the lens cannot be increased, the light cannot be focused onto this point. So if we help the eye to focus it onto the retina, then we can rectify the problem. To do that, we need a converging lens. What is that? A convex lens. So we will see how we can rectify this problem or correcting the long sight. This defect can be corrected by using a convex meniscus lens. I told you all about the convex meniscus lens. Now you all have seen lens in the lab. When we say convex lens, they are curved outwards. So normally you all know the shape is like this. So this is a biconvex lens. But you all know, you have seen people wearing spectacles. Even I am wearing one. Now these lenses are not biconvex. They are not curved outwards on both sides, or neither they are curved inwards on both sides. Instead, they are convex lenses, but in a certain manner, where you have a lens like this. A convex lens, but like a curve shape. That is what we mean by meniscus convex lens. So then, the convex meniscus lens receives the light rays and converges them. The eye lens converges the rays again to focus the image at the retina. So as I told you all, we help the rays to converge on the retina. So we'll see how that is done. Now here again, we have the eyeball there. And the lens is here. Now we are going to use another lens. Now here I am using the normal biconvex lens. I am not drawing the meniscus convex lens. It is the normal convex lens. So we are trying to get the rays that come from close by objects to converge onto the retina. So when there are rays coming from the close by objects, how do they come? They come as a set of divergent rays. So the rays are going to come like this. But initially they fall on the first convex lens that converges the rays. So that will converge the rays like this. Again this lens, the lens inside our eye, will converge it onto the retina. So because of that, we can see the image clearly. Is that clear to you all now? So we have the object, that is close object. From that the divergent rays come, they fall on the biconvex lens. The biconvex lens converges the rays. That again falls on the eye lens, which converges the rays again to form the image on the retina. So the long sight has been corrected and we are able to look at objects that are close by. Do you all understand that clearly? So this is the way the long sight is corrected. And if you are asked to draw the ray diagram, you have to draw this ray diagram. With that, I will move on to the next activity. Let us understand what happens after long sight is corrected. So to understand that, we need these materials. We actually need two convex lenses. Then we need a candle. and we need a screen. So this is what we will do. Using one convex lens, get a clear image of a distant object on the screen. So that is this first diagram. We are going to get a clear image of the distant object. So you all know when we show parallel rays, that means it's a distant object. So you get a clear image. Then what you do is you use a candle that is kept somewhat far away. So get a clear image of a somewhat far object. Not very far. Here we have got for very far object. Now somewhat far object. That is using a candle, and we get the clear image. Now here you can see when this was very far object, the image was very close. The screen was very close to the lens. But here we get an image of an object that is somewhat far from the lens. Then you fix that distance. That is distance, the distance between the lens and the screen. That is the first step. Then we have to continue this activity. What we do is light the candle in front of the lens without changing. Now this is important. Now only we have the lens and the retina. In the previous step where we use somewhat far object, we fix the distance between the lens and the screen. So that is like the lens of our eye and the retina, fixed image distance. So light the candle in front of the lens without changing the distance between the lens and the screen. Observe the blurred image. So earlier we had somewhat far away object. Now we have a close object. So this has become a close object. And we cannot get the image of a close object clearly. It's a blur image. So here you can see this is a blur image. So that is the condition where you have long sight. You saw the far away object clearly. You can't see the close by object clearly, or it becomes blur. So then what do we do? Place the other convex lens between the first lens and the screen. There is a mistake in the procedure, students. Now we have the first lens and the screen, that is the eye lens and the screen. So we cannot wear the spectacles inside. You all know about lens implanting and all, that's a different matter. But here when you wear spectacles, you are going to wear it in front of your eye. So the second lens has to be between the candle and the first lens. So place the other convex lens between the first lens and the object. So it shouldn't be between the lens and the screen, it should be between the lens and the object or the candle. Do you all understand that clearly? We are going to wear the spectacles. So the lens is in front of the first lens. So this is the first lens, this is the second lens. So we keep that there and we try to adjust it a little bit, move it here and there until you get a clear image on this screen. That is what we are going to do here. So place the other convex lens between the first lens and the object. Move it until a clear image of the candle is focused on the screen. So that is what you have to do. Then from this activity, you can understand that when nearby objects cannot be seen clearly, convex lenses can be used to make the image clear. Is that clear to you all, students? So this is the activity that we are going to do now. So first you have the convex lens. You get a clear image of a very far away object, that is the parallel rays. You have a certain distance between the lens and the screen. Then you place the candle somewhat far away from the lens. Again get a clear image, but there you will see that you will have to move the screen a little bit. Once you do that, once you fix that distance, you don't move the lens or the screen. Then you can bring the candle closer. because we are going to observe the close object. And then you will notice that the image will be blurred. So what do? We place the second lens between the candle and the first lens. Then you will be able to get a clear image. So you will be able to understand how the long sight is corrected. So now that you have understood the activity, we will do this in the lab. Okay, students. So now we are going to observe how we can correct the long sight. So to correct long sight, we need to use a biconvex lens. So already I have a biconvex lens here. You all can see I have set it so that we can get the clear image of a faraway object on the screen. Can you all see the image here? It's clear. But you can see the image of the candle is not clear. So now what do? So we can see far objects, the far away, the tree clearly, but the close object, the candle, cannot be seen clearly. So if we hold a biconvex lens, now this is the lens of our eye, this is the lens that will be there in the spectacles. So when I hold it here, now can you all see the clear image of the flame there? Without this, you can't see it. Now with this, you can get the clear image. So that is how we correct long sight. Okay, students. So did you all observe what happened during the activity? I am sure you were able to understand how we can rectify long sight. So we can see the objects far away clearly. We cannot see the close objects clearly. So we use a convex lens to correct that problem. In spectacles, we use the Meniscus convex lens. But in the activity, we use the normal biconvex lens. But you were able to understand how the problem is corrected. So with that, I will move on to the second type of problem, that is the short sight. Short sight or myopia. So from the name you all know, you can see objects that are closer to you very clearly, but the person finds it difficult to observe faraway objects, or the image of the faraway object looks blurred. So let's say you are reading a book, you can read it clearly, but when you want to look at something, maybe the moon or the stars or even a bus coming very far away, a building that is far away from you, those images will not be very clear. So that condition or the defect is known as short sight or myopia. A person sees nearby objects clearly while distant objects appear blurred. And this defect arises because of two reasons. You all know the two reasons. One thing, the eye lens cannot decrease its curvature. Because you all know, students, when you want to observe a far object, the curvature has to become less. So if the eye has the inability to decrease the curvature, then you cannot see the faraway object clearly. That is one reason. Inability to decrease the curvature of the lens. That is one reason. Then you all know, from a far object, it is the parallel rays that come and fall on the lens. So there, when those rays are converged, they converge in front of the retina. The reason is the eyeball can be too long. So another reason or another cause is the eyeball being too long. So inability to decrease the curvature of the lens and the eyeball being too long are the reasons for the defect short sight or myopia. So how can we correct this? Like we did for the long sight, we can correct short sight as well. So here we will have to use a concave lens. This defect can be corrected by using a concave lens. Concave lens. Is that clear to you all, students? Okay. So then we will see how we can do the correction. Let us understand how the vision of a person suffering from short sight takes place. So we will see what happens here. So as you already know, students, you can see the close objects clearly. The rays coming from close objects can be focused on the retina. So the close objects can be seen clearly. That is the normal healthy eye. So here if we look at how that happens, if this is the eyeball and I will draw the lens there. So if it is a close object, what are the types of rays coming from the close by object? They are going to be divergent rays. So if we draw the divergent rays, they will come and fall on the lens like this. So then they converge onto the retina. They converge onto the retina without a problem. So the close by objects or close objects can be seen clearly by the person with short sight. But what happens if they try to focus the image of a far object? Now again, this is the eyeball. That is the lens there. So now the problem is with the far object. How do the rays come from a far object? They come as a parallel rays. The rays coming from distant objects are focused in front of the retina. So if we consider a distant object, the rays have to be parallel rays and they focus in front of the retina, not on the retina. So here you can see the image does not form on the retina. What are the reasons? The eyeball can be too long. So one reason, eyeball is too long. What is the other reason? Inability to decrease the curvature. So inability to decrease the curvature of lens. So due to these two reasons, the image forms in front of the retina. So the image of a distant object is formed in front of the retina. So that is why the person with short sight is not able to see the far away or distant objects clearly. So as I told you all before, we can correct the short sight as well. Like correcting long sight, we can correct the short sight, but we need to use a biconcave lens. Or when we use a spectacles, it's going to be a meniscus concave lens. So we will see how that can be done. Correcting the short sight. So this defect can be corrected by using concave meniscus lens. So here the image is forming in front of the retina. So we have to make the image to form on the retina. And as you all know, concave lenses are diverging lenses. So these are diverging lenses. So then, if we look at how this happens, if this is the eyeball, we have the lens there, then the principal axis here, then what we do is we use a biconcave lens. Now, when it is a spectacles, it's going to be the concave meniscus lens. As I told you all before, you know how we use these two different lenses. Now, the normal concave lens is going to be like this. But if it is a person who has the defect, they are going to wear the concave lens, then of course it is going to be something like this, not curved inwards from both sides. It's not going to be a biconcave lens. Instead, it's going to be something like that. Because in a spectacles, it's difficult to have a biconvex lens or a biconcave lens. So, the best one is the concave meniscus lens to rectify or correct the short side. So, here we are just using the normal biconcave lens. So, from a far away object, the rays come parallel towards the eye. So, what happens is we will be wearing, the person with the defect will be wearing this biconcave lens and the parallel rays fall on the biconcave lens. So, from the parallel rays, the rays get diverged by the biconcave lens. So, here students, you can see these are the parallel rays and the rays are getting diverged by the concave lens. After that, it is easy for the eye lens to focus it onto the retina. So, then the image will form on the retina. Is that clear to you all? So, here parallel rays, then they get diverged, then they get converged, so that the image forms on the retina. That is how we correct the short side. So, this defect can be corrected by using concave meniscus lens. The rays from the object are diverged through the concave meniscus lens and the eye lens converge them to a point on the retina to make the image clear. So, I am sure you all can understand what happened here. With that, I will move on to the next slide. Activity. Let us understand what happens after correcting the short side. So, as you know, to correct the short side, we use a concave lens. So, to do this activity, we need two lenses. One is a convex lens and the other one is a concave lens. So, here students, since we are doing the activity in the lab, we will be using the normal biconvex lens and the biconcave lens. And as the object, we need the candle and here we need the screen as well. So, screen is going to be similar to the retina and the convex lens is going to be the lens in our eye. So, we will see how we are going to do this activity. The method. Light the candle in front of the convex lens and get a clear image of it on the screen. So, we are going to see how short sight can be corrected. So, when we say short sight, close objects can be seen clearly. So, here we have a close object and we get the image. So, we get the clear image here. That is our first step. And at that point, we fix the distance and that is going to be the distance between the lens and the retina, similar to that. So, here D is the image distance. Once we fix that, what do we do? When the candle is kept far away, so now we have the close object, we got the clear image, we have fixed the image distance, we move the candle far away to see how short sight occurs. So, when the candle is kept far away without changing the distance between the lens and the screen, that is distance D, we can get a blurred image. So, that is the short sight. When we get the blurred image, it is the defect, short sight. So, the D is not changed, but we have moved the object distance, far object. and here we get the blur image. Blurred image. Do you all understand up to here? So this is the defect of the eye, short sight. Now we have to correct it. So we'll see what we do next. Then what we do is we place a concave lens between the candle and the first lens. So this is going to be the convex lens. And this is the concave lens. That is the lens in our eye, similar to that lens, and the screen is similar to the retina. The distance is still fixed. We could not see this candle clearly. We only got a blurred image before. So what we do is we use this concave lens between the candle and the first lens. We have to move it a little bit so that we get a clear image on the screen. So place a concave lens in front of the convex lens and move it till a clear image of the candle is formed on the screen. So is that clear to you all now? This is similar to wearing spectacles. So when we do that, you will be able to see a clear image. I am sure you understood the steps of the activity. So we will do that in the lab now. So now students, we are going to observe how we can correct short sight. When we say short sight, you can observe close objects. So we should be able to observe this candle clearly. Now let me adjust. Now this is the lens of our eye. With that, I will make the position of the candle clear. Can you all see the image of the candle on the screen? Is it clear? Yes, we can see it. But we cannot see at this part, you can see the image of a faraway object, but that is not clear to us. If I use a biconcave lens in front of this lens, why this is the lens of our eye, we will be wearing the spectacles. Now with this lens, can you all see the clear image of a faraway object? You can see the leaf of a tree. When I move it, it becomes blurred, but at a certain position, you can see the clear image, and that is also an inverted image. So you all can understand now when we have short sight. That is, you can see close objects, but you can't see far objects. We can use a biconcave lens in order to get a clear image. That is how short sight is correct. Okay, students. So, did you all observe the activity clearly? Did you see what happened? Yes. When I had the candle, that's the close object, with the biconvex lens, you were able to see the image clearly. But when I try to move the candle and also during the activity, I try to focus the image of a distant object, a plant, you could not see the image clearly on the screen. Afterwards, I held the biconcave lens in front of the biconvex lens, that is between the biconvex lens and the object. Then you were able to see the image clearly. So that is how short sight is correct. It can be understood that when distant objects cannot be seen clearly, that is when distant objects cannot be seen clearly, concave lenses can be used to get a clear image of the distant object. So here we use a concave lens. Is that clear to you all, students? So far we have discussed the two defects of the eye, that is long sight and short sight. And with the activities, you all were able to understand how long sight can be corrected using a convex lens and how short sight, that is this, can be corrected using a concave lens. So with that, now I am going to move on to a new topic, that is binocular vision and stereoscopic vision. Binocular vision and stereoscopic vision. Now you all are very familiar with the structure of the eye, and now you know how image forms, how defects can occur and how we can correct them. In addition to all this, our eye has two special properties, that is binocular vision and stereoscopic vision. Now understand the term binocular. Bi means two. Nocular, that word means or refers to the eye. So we see using two eyes, binocular vision. Now we'll see how that helps or improves our vision. The eyes of human. Now here you can see eyes of human, that is us. Then you can see monkey shown in the diagram. Then Rilava or Mandi here. You can see the Rilava or Mandi. They are all similar type of mammals. Similar, not the same, similar. Then we have the chimpanzee. Here you can see the chimpanzee. Then the gorilla and the loris. So all these, look at all of them. Look at our eyes and look at all these animals or the mammals. The eyes are situated in front of their face. So when I look at you, you know that both my eyes are in front of my face. So because of that, I can see the same area with both my eyes. That gives a better vision or more clear vision. That is what we call as binocular vision. The eyes of human, monkey, Rilava or Mandi, chimpanzee, gorilla and loris are located in front position of the skull. As I said, front of the face or the front position of the skull. So there is a greater chance of seeing the same area with both eyes. So when I look at you, I am looking at you with both my eyes. Sometimes as children you would have tried this. You close one eye, you look at an object or a person with one eye. So you have an idea as to what this binocular vision is. So we will try to understand this in little bit more detail. So that I will move on to the next slide. Now mammals such as cattle, dog, tiger have no ability to look at the same area using both eyes. So you can see the cattle here, the dog and the tiger. What is the difference? Now look at the face. Now in this dog or all the animals you have seen them, so you know their eyes are situated on either side of the skull or the face. So with their right eye, they can see the area on their right hand side. And with the left eye, they can see the area more clearly, that is on their left hand side. They can only see a very small area that is in front of them with both eyes simultaneously. So that is the difference here. So they can look more area separately using each eye. Now we look at the same area with both eyes. That gives us a clear vision. That is what we call as binocular vision. But here these animals look at the areas on either side. So they can't see the same area with both eyes, or they see only a small area with both eyes together. But they can look at areas separately. So that is the difference. You all are familiar with this because you have seen all these animals and you know how their eyes are. So now we will try to understand this binocular vision in little more detail. The ability to maintain visual focus on an object with both eyes, creating a single visual image, is known as binocular vision. That is the important thing. You use both eyes, you can focus on many objects, but the focus creates only one image. That is known as binocular vision. So the ability to maintain visual focus on an object with both eyes, creating a single visual image. So what you can do is you can look at an object in front of you. You can close one eye. Let's say you close your right eye, look with your left eye. Then you close your left eye, look at the object with right eye. At the same time, you can look at it using both your eyes. You will be able to understand how more clearly you can see the objects when you use both your eyes. So that is because of the binocular vision. Now look at these two diagrams. The human has a broader range of binocular vision. That is what is explained here. If we try to understand this diagram, now here see a person is looking at this scenery. At the same time, a dog is looking at the same scenery. Same thing is in front of them. So when a person is looking at something in front, you can see here, now this is his vision range. This whole area is his vision range. Now this area is the vision range. Now in this, if he only uses now if I am the person there, if I only use my left eye, then I will be able to see this particular area. So this is with the left eye. That is, if I close my right eye and use only the left eye, I can see this region. The same way, if I try to close my left eye and observe only with my right eye, I will be able to see this region. Now, in both these, can you see this common area? This area is common to both eyes. That is about 140 degrees. And that is the range of the binocular vision. Because you can see with the left eye here and with the right eye here. This area is common to both eyes. So that is the range of the binocular vision. Now look at the diagram here. As I told you, this part is where you see with the left eye. This part is where you see with the right eye. And this area, the 140 degrees, is the area which is seen by both eyes, the range of binocular vision. So here you can see this area is 140 degrees. But this whole area that can be seen with the left eye is 170 degrees. So we can only see 30 degrees with the left eye only. That is not visible to the right eye. The same way, on this side if you see, this whole region is there. That is 170 degrees. Out of that, this part is 140 degrees. So here again there is 30 degrees. So 30 degrees is the region that we can see only with one eye on the side. So with the left eye, you can see 30 degrees. With the right eye, you can see 30 degrees. But with both eyes, you can see 140 degrees. So now if we look at how a dog's vision is, the binocular vision of a dog. So here you can see again the dog is looking at the same area. So for the dog you can see there is only 150 degrees. So if we try to understand their vision. Now here this is the region that can be seen by the left eye of the dog. The same way, if we take the region that can be seen by the right eye of the dog, here also you can see it's going to be this region. So this is the area that can be seen with both eyes, the left and the right eye. So that is the range of binocular vision. What is that range there? You can see it's only 60 degrees. So now can you all see? Now we have 140 degrees of binocular vision, but the dog only has 60 degrees of binocular vision. But look at the rest of the area. Now this whole area or this region, the visibility range is 150. Out of that, this part is 60 degrees. So this will be 90 degrees. The same way for the left eye as well. Here also the range will be 90 degrees. So now can you all understand? The dog can see a larger area with the left eye alone. So that's only on the left side of its face. The same way, it can see 90 degrees, a wide range or a broad range you can say, compared to our vision that is 30 degrees, it can see on its right side. But with both eyes in front, it can only see 60 degrees. So compared to us, a dog has a very narrow region of binocular vision. Is that clear to you all? So we as the advanced mammals, man, as well as the other examples we saw before, monkey, gorilla, mandi, loris, all these animals, they have a broad range of binocular vision. Whereas cattle, dog, tiger, all these mammals have a smaller range of binocular vision. Or because their eyes are situated on either side, their range of binocular vision is very small. This gives us an advantage. So the binocular vision gives us an advantage. It leads to the stereoscopic vision where we can judge the depth and the height of objects. So that is the advantage we have over some of the mammals that have their eyes located on either side of the skull. Because we have the eyes in front of the skull, that gives us a broader range of binocular vision. Now we will try to understand a little bit more about binocular vision. Identify your range of binocular vision. So this is an activity that we don't need to use the lab. We are not going to the lab. This is an activity which you can also do it on your own. So this is to identify or understand the range of your binocular vision. To do that, what do you have to do? Keep the face straight and look forward. So now since I am talking to you, I am moving my face here and there. But when you are doing the activity, you have to keep it straight like that. And you have to look forward. And then you have to stretch both your hands in front. So do the following things without moving the face. Stretch your hands and fold your fingers. Straighten the thumb right upwards. So you have to stretch your hands, fold your fingers, and your thumb have to be straight upwards. Then what you have to do is you have to close your left eye. You can't close it with your hand because you have to use your left hand. So if you can do it, I'm sure you are able to close one eye and look with the other eye. So you can do it easily. You have to close your left eye and you have to move your left hand. So I have both my hands stretched forward. I close my left eye. I have to move my left hand up to the point where I can see it with my right eye. So if I have it like this, I close my left eye, I move the hand, but you shouldn't move your face. Now somewhere up to here, I can see it with my right eye. So that is the range on this side. The same way, I have to close my right eye. So same way, you have to either ask your friend to close it or you can do it on your own. So now students, I have found the range for my left side. Up to here, I can see with only my right eye when my left eye is closed. The same way, you have to close your right eye and move your right hand. So here, I have to move my right hand and look at it with my left eye until I can see it. Now, if I take it further, I can't see. So, up to here, I can see. So, this is the range. Now, when I open both my eyes, I can see both my thumb. So, that is my binocular range. Is that clear to you all? So, this side, the range that you can see with your right eye. And on this side, the range that you can see with your left eye. Is that clear to you all? So, you keep the face straight and look forward. Do the following things without moving the face. Stretch your hands and fold your fingers. straighten the thumb right upwards. Now here, because I was explaining it to you all students, sometimes I would have moved my face a little bit. But when you all do it with a straight face without moving your face. Close your left eye and move your left hand in the horizontal plane to the left until you cannot see the thumb. Keep the left hand in the same position and close your right eye. Now move your right hand in the horizontal plane to your right until you can't see the thumb. Now look at both thumbs using both eyes. So you were able to find your binocular region. And as you can remember, mammals, us, we have 140 degrees of binocular vision, whereas the dog had only 60 degrees of binocular vision. I am sure you were able to understand that. So with that, I will move on to the next slide. So your eyes can see the objects which lie in the range of the stretched hands. It is your binocular range. But when the both eyes are open, the objects seen to the left of the left hand can be seen only by the left eye. Similarly, the objects to the right of the right hand can only be seen by the right eye. So that was what we did know. When I move my hand this way, after one point, after this point, I couldn't see my left thumb because my left eye was closed. But now, with my left eye open, I can move it further. Still, I can see my thumb. You also can do it and see. The same way, if I stretch my right hand, I still can see it if my right eye is open. So that whole range is the range of our vision. That is about 170 degrees. That you all were able to understand from the diagram before. Due to the binocular vision, human has got the stereoscopic vision. This is important. Earlier also I mentioned this to you all. Having binocular vision is an advantage. We have better vision. So due to this, we have stereoscopic vision and the ability to determine the distance of an object. This is very, very useful to you all. Because when you try to walk, if you know the distance, if you can judge the distance, it's easy. When we write also, when you draw pictures, basically for all the activities we do, it is an advantage being able to understand the distance or determine the distance of an object. So, stereoscopic vision means the ability of the eye to determine the depth of an object or the height of an object. This is very, very important. So, because we have binocular vision only, we are able to determine the depth or the height of the object. So, that is very useful to us. Is that clear to you all students? So, now we will try to understand what this stereoscopic vision is. So, activity, let us understand that stereoscopic vision is the ability of the eye to determine the depth of an object or the height of it. So, to do that, we need to have a pen. Now, I have a pen with me. Hold the clip of the pen, keeping its hole upwards in a distance. When you stretch the hands to your front. Close one eye and insert the pen into the clip. Insert the pen again into the clip using both eyes. Compare the difference of ease in both situations. So, a very simple activity. Again, we don't have to go to the lab. You can do it by yourself. A very simple one. So, what you have to do is you have to hold the cap of the pen in front. You have to close one eye and you have to try to insert it. With my right eye closed, I can't insert it into the cap. Even if I try with my left eye closed, the same thing. It's difficult. But if I have both my eyes open, I can easily place it into the cap. That is the stereoscopic vision. With both my eyes open, I have the binocular vision that provides the stereoscopic vision. So, I can easily judge the depth or the height of the object. So, I can easily insert the pen into the cap. Is that clear to you all, students? So, here you can see it is easier to insert the pen into the clip by seeing through both eyes rather than seeing through one eye. This is because of the stereoscopic vision of the eye. So, now can you all understand the better effects we have or the better abilities of our eye? We have the ability to change the curvature of our lens so that we can see close objects and far objects. Then we have the binocular vision where we have a range that is seen by both eyes but only one image is formed. So, that gives us better vision. Because of that, we have the stereoscopic vision which helps us to determine the depth or the height of an object. So, this is not there for all the mammals. Only some of the mammals have very high range of or broad range of binocular vision and therefore stereoscopic vision. So, did you all understand that clearly, students? I am sure you were able to understand. So, with that, I will move on to a new topic, that is the eye diseases. So, students, now we are going to discuss the eye diseases. This is different from eye disorders, and two common eye diseases can be identified today. So, those two are cataract and glaucoma. So, if I write down the two diseases, cataract and glaucoma. Now, we will discuss what these two diseases are one by one. Cataract. So, cataract is a cloudiness or opacity in normally transparent crystalline lens of the eye. I will explain that to you all. Look at this diagram. Now, here this side you can see the lens of a healthy eye. So, this part you all are familiar with the structure of the eye. Outermost layer is the cornea. You all know that is transparent. Then behind the cornea there is the aqueous humor that also allows light to pass through. And this dark colored region, that what you see is the iris. Iris is usually dark in color. And in the middle there is the pupil, the pore that allows the light to go in and get refracted by the lens. So, that is the healthy eye. Here you can see the difference. Now, this is the lens of a diseased eye. Here you can see it has become whitish in color, not transparent or opaque. Here it's black color or the dark color is due to the iris, but here it looks whitish in color. The reason is the lens has become opaque. Can you all understand that? The lens that has to refract light has become opaque. It has lost its transparency, or the transparency of the lens has been reduced. This actually happens step by step. It doesn't happen at once. Little by little, the transparency gets reduced and the lens becomes opaque. And if it is a very later stage of the disease, then of course the lens can become completely opaque. So, here a cataract is a cloudiness or opacity in normally transparent crystalline lens of the eye. Now, this happens due to a process called denaturing of proteins. Now, our eye lens, they are made up of proteins. Now, think of this. You have seen the egg at home. You all have seen people frying eggs. Maybe you would have also fried eggs. Now, in the egg, we have the egg white. As you break the egg, is the egg white in color? No, it's usually transparent. That is protein. But when you fry it, what happens to the egg white? It becomes whitish in color. So, the transparent egg white that is present in the egg when fried, becomes the whitish color substance. That is, the transparency becomes opaque. Same thing happens inside our eyes. The lens of our eyes is usually transparent. It is a protein material, and due to certain reasons like aging or conditions like diabetes, this lens loses its transparency due to the denaturing of protein. So, it becomes whitish in color, similar to the egg white when it is fried. So, it is because of the denaturing of proteins in the eye. Then, eye lens turn to milky color, that is this. So, here it is the transparent lens, and here this is the milky color lens. Do you all understand that? So, and remember students, this doesn't happen all of a sudden. It happens gradually. So, with that, I will move on to this slide. So, here, cataract prevents the light rays coming from an object focusing properly on the retina. If we look at how cataract occurs. Now, look at the two diagrams. Now, this is an eye of a healthy eye. This is a person who has a healthy eye. You can see the normal lens, and here you can see in the middle the pupil and the iris, they are black in color. But if we look at this diagram, this picture, you can see here there is opacity. That is, the transparency of the eye lens has decreased. So, you can see a white color region there. So, that is an eye with cataract. So, here, cataract prevents the light rays coming from an object focusing properly on the retina. Then, all the objects are seen blurred. So, this is what happens. Look at the eye diagram here. Now, this is a normal eye, a healthy eye. The light rays that are coming in, they are refracted by the eye lens, and here you can see the image is formed on the retina. So, the information will be taken to the brain. So, you can see the object clearly. But in the second diagram, can you see the rays coming from the object? That is the same way. But here, can you observe the lens there? It's opaque. The opacity of the lens has increased, the transparency has decreased. So, because of that, you can see the light rays are being scattered. You all are familiar with transparent objects and opaque objects. Normally, the transparent objects allow light to travel normally, or maybe they refract light. But the opaque objects do not allow light to go through. When there are translucent objects, now here you can remember, because of the denaturing of the protein, little by little, the lens becomes opaque. So, therefore, a certain amount of light rays can enter through the lens, they get refracted, but most of the light rays, can you see here, they are getting scattered. So, here, due to the reduction in transparency, light rays are scattered. So, therefore, the image is not focused properly. So, here you can see cataract prevents the light rays coming from an object focusing properly on the retina. That is the problem. So, here students, you can see the opaque lens. So, now do you all understand what happens there? In a healthy person, the eyes are healthy. The light rays enter into the eye, they get refracted by the lens, image forms on the retina, you are able to see the object. When the proteins get denatured, the opacity increases. Because of that, the image does not focus properly on the retina. Therefore, the person cannot see the object clearly. So, that is the condition that is known as cataract. Now, we will try to understand how this vision changes. Now, look at the two pictures here. The first diagram, you can see a very clear scenery. That is how a healthy person, a person with healthy eyes, sees the object clearly. So, he can or she can identify the trees, all the scenery, everything, all the objects are clear to them. But look at the second diagram. The diseased eye sees the objects blurred. So, because the transparency has reduced, the person sees the image in a blurred manner. They know that there is something in front of them, but they can't really see a sharp image. They cannot see the object clearly. So, you can see these two diagrams. Now, imagine you have an oil paper in front of you. You all know about oil papers. They are not transparent. They are somewhat translucent. They allow only a small amount of light to travel through and they scatter the light. So, if you are holding an oil paper in front of you, how will you see the image? It will be blur. The same way, a person with cataract, the light rays are scattered. So, because of that, they see a blur image. That is what is shown here. So, this cataract is caused by two main factors. Generally, cataract may occur with age and genetic factors. So, with age, because you are using the eye for over a long period of time, with age, the proteins in the lens get denatured. Because of that, the transparency decreases. That is due to age. Then there is a genetical factor. In some families, due to their genes, they have a high tendency of getting cataract even sometimes at a younger age. So, that is the genetic factor. Two factors, age and genetical factor or genes. Then there is another one. It is believed that ultraviolet rays reach the earth through the holes of the ozone layer, affect towards the occurrence of cataract in the eye. Now, if we think about this ozone layer, you all know we have the earth here. Around the earth, there is the atmosphere. This is the atmosphere. And in the atmosphere, there is ozone gas. Now, this ozone gas absorbs UV. UV is the ultraviolet rays. UV rays. Say if this is the sun here, there are UV rays coming from the sun and these rays are absorbed here. But if there is a hole, now here you can see if there is a hole. Hole means not a real hole, but what happens is the amount of ozone decreases, that is known as depletion of ozone layer. Because of that, let's say we take this region where there is less amount of ozone. This is a hole. So then what happens is the UV radiation that is coming from the sun directly reaches the earth. So that can lead to cataract. So here you can see it is believed that the ultraviolet rays, so here this again is the ultraviolet rays, reach the earth through the holes of the ozone layer, affect towards the occurrence of cataract in the eye. So that also leads to cataract, or it increases the percentage of occurrence of cataract in people. So now, are you all clear with those students? You know what cataract is and the two main causes, age and genetical factor. They can lead to cataract, but cataract occurs because of the denaturing of proteins. And then the UV radiation that is coming from the sun can also give rise to or affect towards the occurrence of cataract in the eye. So that is the first type of disorder. Now I will move on to the second type, that is glaucoma. So glaucoma. Glaucoma is a disease that gradually reduces the visual range of the eye and leads for blindness due to damage of the optic nerve. I will explain that to you all. So here you all know this is the eyeball and here is the optic nerve. Here is the retina and we have the lens there. So the light rays that are coming from the object, they converge onto the retina, forming the image. So there's no problem, image is formed, the retina is working and the information or what we call as the visual sense has to be taken to the brain by the optic nerve. So here the important factor is the optic nerve. Here you can see the optic nerve carries the information to the brain with certain factors. Again, it can be due to age or it can be genetic factors, and sometimes in diabetic patients there is a high tendency where the optic nerve gets damaged. This happens due to high blood pressure. So, if there is high blood pressure in the eye, that damages the optic nerve. And because of that, although the light rays are refracted by the lens, the image forms on the retina, but this information cannot be carried to the brain. So, that leads to the reduction in visual range. So, this is how it happens. In a healthy person, let's say if this is the visual range. Now, here this is the visual range of a healthy eye. When they are affected by glaucoma, what happens is the visual range gets decreased to this region. And if it's over a longer period of time, further the visual range decreases and finally it can lead to blindness. So, if we go back and see what glaucoma is, you can see here glaucoma is a disease that gradually reduces the visual range of the eye. So, here the visual range gets gradually decreased and leads for blindness. So, finally the person becomes blind due to damage to the optic nerve. By detecting at the first stage, further increase of glaucoma can be controlled. So, what you can do is at the initial stage, if you detect glaucoma, then you can prevent further damage. But the damage that has already been caused cannot be reversed. You can't retrieve the vision back to the normal range, but you can prevent. Maybe when the visual range is reduced to this first range, you detect the condition and thereafter you get the treatment and then the visual range will remain there. It will not decrease further. That is the only way of treating this. So, glaucoma is usually the result of high blood pressure inside the eye. And a person with diabetes has an increased risk of developing glaucoma. I mentioned that to you. The damage caused to the eye cannot be reversed again. So, you cannot reverse the damage. So, I am sure you all can understand this condition clearly. Now, I will move on to the next slide where I explain how the visual range decreases. I will move on to this slide where we have 4 pictures again. Now, if you look at figure A, the figures A, B, C and D shows how a glaucoma patient loses his vision gradually. Look at figure A. Now, that is a normal healthy person, how he sees the scenery. So, there it's very clear. But look at B. Now, this has become a little bit more darker. The same time, a person with the initial stage of glaucoma sees it a little darker, and especially this region you can see is more dark. And this part is somewhat clear. Then with time, if not treated, it will become like this. The third stage, where it is known as the middle stage of glaucoma, the region has decreased further. And finally, the third stage, like the final stage, you can see only a very small range, only this much. Now here it was a little bit more larger. Then later, if it develops further, you can become completely blind. So A is the healthy eye sees the objects clearly. This is the healthy eyes. Then first stage of glaucoma is B. Middle stage of glaucoma is C, and final stage of glaucoma leads to vision loss or blindness. So this is something important. At this point also the person can see a little bit, but the range has decreased to a great extent. After that, it will lead to blindness or vision loss. So students, so far we have discussed the two types of eye diseases. One is cataract, the other one is glaucoma. But remember, these two diseases are not contagious. If you sit next to a person who has cataract or glaucoma, that doesn't come to you, because those are either by genetics or due to aging or diabetes, ultraviolet radiation. So those are conditions that is not contagious. But what we are going to discuss next is a disease that is a contagious disease. So that is eye infection. And this is caused by a virus. In addition to above mentioned diseases, eyes can be infected by viruses. So you all know there are many microorganisms that cause diseases, and here virus causes infection to the eye. And that's something that's familiar to you all students. Usually during very warm days, the eye infection is very common. This is what we call as sore eyes. You would have seen people, the eye becoming red, they'll be tearing all the time. Then there is the sticky substance that is produced. Because of that, the eyelids get stuck together. You find it difficult to open your eyes. And when it is a severe situation, you get a pain in the eye as well. So that condition is known as sore eyes, and that is the infection caused by viruses. So symptoms are reddening of the eye and secretion of tears. You can see that in this diagram. Now this side is a healthy eye. This eye has been infected by a virus. And this eye infection, it can be caused to one eye. Usually what happens is you get the infection on one eye, then it spreads to the other eye. But for some people, it's only to one eye. Or else sometimes you can get it on both eyes at the same time. So that depends on how you get infected. So here you can see the symptoms, reddening of the eye and the tearing. The disease spreads through insects, konduruwa, and by contact. So it can spread through insects. Say if the insect carries the virus, it can spread from one person to the other. Now say when you are tearing, say you use your hanky to wipe off your tears. If you place it somewhere, an insect comes and stays on that, the virus gets stuck to the insect's body. Then from there, it can be spread to another person. Or otherwise, if two people are sitting close to each other, and when one person has sore eyes, due to the tears, due to contact, the other person can get it. So this is a very, very contagious disease. It's not dangerous, it's not fatal, but it can be spread very quickly. So you have to be careful. And this condition is known as sore eyes. And it can be cured by medical treatment. So I'm sure you would have either got sore eyes or you would have seen someone having sore eyes. Normally when you go to the doctor, they prescribe medical ointments as well as medicine. So sometimes you're supposed to put a cream into the eye itself that can cure the disease. But you have to make sure you get the medical advice. Without doctor's prescription, without medical advice, you can't just go and buy a cream or a medicine and put it in your eye. You have to be very careful with that. But it can be treated and it's not fatal or dangerous or anything. So that is the eye infection. So with that, we have finished the diseases related to eyes. Now you all can remember we discussed disorders, that is inside the eye, short sight and long sight because of defects of the eye. Then we discussed the eye diseases, cataract and glaucoma. And this is the infection caused to eye. So with that, I will move on to the next slide where we discuss how to protect or maintain the health of the eyes. Precautionary measures should be followed to prevent health problems and possible defects of the eyes. Such precautions are given below. So these are precautions that you need to take in order to protect your eye or to maintain the health of your eyes. Protect your eyes from harmful light rays. What are harmful light rays? We discussed one, the ultraviolet light rays. How can you protect it? You can wear sunglasses or sunshades or avoid looking at the sun directly, especially during the time of eclipse. Do not look at the sun directly. So all these to protect your eyes from harmful light rays like UV rays. Then sometimes you would have seen these small children, you have these pointers that are used to point at the maps or diagrams on the wall. When they get hold of a pointer, what they do is they like either to their eye or their friend's eye, they tend to point it into the eyes. Although that ray is usually not harmful, but if it's directly pointed into the eye, it can cause problems. So there also you have to be careful. Then sometimes again children, playfully what they do is they try to shine the torch into the eye. So if it's too bright light, that also can cause problems. So you have to be careful. Protect your eyes from harmful light rays like UV radiation. At the same time, you have to be careful not to look at very bright light. Then you can see, do not look at the sun directly at a solar eclipse. So you all know what solar eclipse is. When the moon comes between the sun and the earth, the sun gets covered, and at that time there is a very high amount of radiation being emitted by the sun. And if you look at that directly, that can cause a lot of problems to your vision. So do not look at the sun directly at a solar eclipse, and necessary safety methods should be used to look at the sun in such situation. You all know those. You have to either use very protective glasses, look at it through certain X-ray papers like that. There are different methods, or else you can have a bucket of water and look into that water. You can see the shadow of the eclipse inside the water. That is also possible, but you should never look at it directly. So that is another method. Be sure to wear safety glasses when do welding. You know what welding is. When they want to fuse or fix two metals together, two steel objects together, they use the oxyacetylene flame. That's a very bright flame. And you all have seen people when they do this welding process, they wear the goggles or the safety glasses, or else they hold a shield in front of them, a safety shield. Some people do both. They wear the goggles as well as they hold the shield as well. So then their eyes are protected. So when someone is doing welding, they take protective measures. You also should not look at it. So you have to be careful. Then the next one, do not use eye drops or any other liquids into the eye without medical advice. So when I discuss the eye situation, eye disease, eye infection, I told you all you can treat it with medication, but you have to get the medical advice, doctor's advice. Without that, don't put anything into your eye. Even when you have a bath, when you have a head bath, if shampoo or something goes into eye, you have to make sure you wash it well with lot of water. Or in the lab when you are doing some activity by mistake, if there is even a small drop of something that goes into eye, then immediately you have to wash it with lot of water so that your eye is safe. You have to remember that. Then do not use someone else's spectacles. This is again a common thing, students. Not only small children, I have seen sometimes in school also you tend to just for fun, you tend to wear the friend spectacles, your friend spectacles. So what happens is your eye does not have any problem. The person who is wearing the spectacles has an eye defect. If you try to wear that spectacles, then your eye gets used to that spectacles. Automatically, you generate a disorder in your eye. So because of that also, you should not wear someone else's spectacles. Even if you have the disorder, you are wearing spectacles, another person is wearing spectacles, the power of the spectacles will be different. Then also you should not switch the spectacles. So even when wearing spectacles, wearing sunshades or sunglasses, it's always better to get the medical advice. So you have to be careful there. When using sunglasses, follow medical advices, what I just told you. Should care for personal hygiene. So you know that there can be infections caused to the eye. So that again can be prevented by personal hygiene. If you don't touch your eyes with, unclean hands. So you have to always wash your hands, wash your face, be clean so that the eyes do not get infected. The same way, you go to the lab, maybe you touch the surface of the working table, there can be chemicals on it. Then if you place your hand inside your eye, then the eye can get damaged. So to prevent that, you have to wash your hands first and then you have to touch your face. So by maintaining personal hygiene, you can prevent lot of problems caused to the eye. Do not watch television and use computers continuously or take precautions to minimize the damage. That is also very, very important, students. Television and computers. And nowadays, as you all know, we are very much used to TV, computer, mobile phone, tabs. All these are very common to us. Even for studying purposes, even now you are watching either one of these screens. So then, what should you do? You shouldn't watch it continuously for a long period of time. Even if it is studying purposes, you can obviously pause the video. You have to take a break. How do you take a break? You stop the computer, go and watch your phone? No. You have to avoid the digital screen. It can be TV, computer, mobile phone, tab, anything. You have to avoid the screen. So if you at least use it for half an hour, it's really advisable if you can take 10 minutes of break. But if that's not possible, at least every 1 hour, you can take a break. So it depends, students. I'm not telling you all to have a fixed time, but you have to make sure you take a break. How do you take a break? You can either look at a natural thing or you can just keep your eyes closed. Some people even close their eyes with their hands to make it more comfortable. So like that, you have to take breaks while you watch TV or computer screens. Is that clear to you? That is very, very important. Your health should be your priority. So even if you feel like watching the movie continuously for a long time, still you have to remember you have to protect your eyes. So you have to take a break. So these are the precautionary measures that should be followed to prevent health problems and possible defects of the eye. So you all can understand all these, and I am sure you will follow all these and keep your eyes healthy. So with that, students, I have come to the end of discussion on eye. So in this lesson, we are going to discuss 2 types of sensory organs. I have completed the discussion on eye. In the next chapter, I will discuss the structure and functions of the ear.